Welcome to EDU World Space.
Okay, so for this one, we need to look at our figure 11 in the book, and we have a synthetic light curve of RR Centauri. It's an eclipsing binary star, and two components are in close contact, and we're given orbital and physical characteristics, and a spectral classification. And for part A, we want to indicate the approximate points on the light curve as a function of phase that correspond to the orientations depicted. So if I am looking at the figure and going from upper left to lower right, the images correspond to phases of about 0.00, about 0.06, about 0.13, about 0.19, about 0.25, about 0.31, about 0.38, about 0.44, and is about 0.5. So this is just directly from looking at that graph. Now part B, how do we explain this qualitatively? Well, in the binary system, in this one at least, this larger star is hotter. And this is because at the primary minimum, the maximum amount of that larger star is covered, which means that it's going to have the least total luminosity. Because a lot of that star, or a max of that star, is covered at the primary minimum. Okay. Also, the primary minimum in this case is not flat. And this is because of the proximity or the closeness to the second star. And in fact, this is what we say leads to something called tidal distortion. In other words, the spherical symmetry is removed. So anyway, the brightness of your system keeps increasing approximately until you get about to a phase of about 0.25, and both stars are seen if we look at the information given. Now, as the secondary one passes behind the first, so now as the second star passes the first, you see that the brightness decreases. You get a decrease in brightness, eventually reaching a flat plateau at about 0.5. And this guy's going to be flat because we say the distortions are for a finite period of time, for some time. And that's how you describe it.